All right, let's pick up where we left off in example 3. We did the unit circle, but now we're coming back. Remember, this problem was called a two's-clue problem? Two's clues problem? Yeah. And this will essentially be what your free response looks like on Wednesday when we take our test. It won't be like guys running around tracks or anything. Wednesday the 6th, yeah. Next Wednesday we're testing over everything we did before and this new section. Okay. Well, heavy on the new stuff, but anything from what we did before. How about that? But the free response will be like this. It's a two's clues problems. That'll work. So this chart here, you don't have to memorize this, okay? This chart just tells you where things are positive or negative. You don't need to know that because why? You know the definitions in terms of x, y, and r, and you know that r is always what? Positive. So the sign of the trig function is determined by the sign of x and y, all right? Okay, so let's look at example 4. It's a better two's clues problem because this one was kind of boring because we only needed that second clue. That's not how they're going to be given to you. So example 4, if tangent of some angle theta is 5/12 and cosecant of the same angle is what? Negative, less than 0. That's a better clue. Well, if you like mysteries, it's a better clue. If you don't like mysteries, that's a horrible clue because we have to work a little harder. Determine, again, the simplified exact values of the other 5 trig functions. And then after that, we'll find theta and theta ref in degrees. Okay, so tangent is 5/12. Let's come down here. All right, a little smaller here. There we go. Tangent of theta is 5/12. What is the definition of tangent in terms of x, y, and r? Y over x. Good. So y and x can both be positive or negative, right? So if I have a positive tangent ratio, it's because either y and x are both positive. Would you agree? So it's going to be somewhere over here in quadrant 1. Or what else could they be? They could both be negative. It could be negative 5 over negative 12, right? Which would put me in what quadrant? 3. Okay, so it could also be over here. This could also be the angle theta. We don't know. We'll call one theta 1 and theta 2. Now remember what we did last time? There's always going to be 2 quadrants that work based upon a single trig function. And those quadrants are going to have the same reference angle. This angle here and this angle here are going to be the same. And you can actually tell from geometry now because those are called vertical angles. Remember that? And vertical angles are congruent. So when you drop a perp right here or the same place over here, these 2 triangles are going to be congruent. So let's go ahead and label the sides based upon what we have. Y could be 5 and x could be 12. And that would give us this triangle. Or, let's use a different flavor. Y could be negative 5 and x could be negative 12. So notice the x and y are vectors, right? But if you're talking about lengths, you're talking about the absolute value. So those 2 triangles, the red and the green one, are congruent. And they always will be. Based on a single trig function, the 2 quadrants that you get into, your reference triangles will always be congruent, and your reference angles will always be the same. Okay? Could an x be negative and a y be positive? Well, if you did that, what's a negative divided by a positive or a positive divided by a negative? It would be a negative. So yeah, if we had a negative tangent ratio, which is not the case here, x and y would be opposite signs. And that would put you either in quadrant 2 or quadrant 4. So with a little bit of experience, you'll realize that tangents and cotangents options, they always happen in vertical quadrants, okay? So you draw a straight line all the way through, okay? Whereas the sine quadrants are going to be side by side vertically, and the cosines are going to be stacked up and down vertically. But if you just know the definition in terms of x, y, and r, you can get there. Okay, so now I need another clue, right? I need to know which one of those it is. Is it the angle between 0 and 90, Or is it the angle between 180 and 270? How am I going to figure that out? Well, clue number 2, cosecant of that same angle is less than 0. What is the definition of cosecant in terms of x, y, and r? R over y. Y is always positive, yes? So that's a positive r, and if the ratio is negative then, it's because what is negative? The y is negative. Oh. Very good. Y is negative below the x-axis. Okay, that's quadrants 3 or 4. So the overlapping quadrant is quadrant 3. This is the quadrant that meets the tangent requirements and the cosecant requirements to be negative. It's below. So there it is. Our angle is theta 2. That's the one we want. All right, so now we can find the third side by the Pythagorean theorem. So negative 5 squared plus negative 12 squared equals r squared. Yes? So what do you get? 25 plus 144. Right? Yeah. Be careful with those negatives, right? You need them in parentheses if you're going to put them in there. 25 plus 144 is r squared. So you get r squared equals 169, which is the perfect square of 13. So do we take plus or minus here? Not here, right? Because in this case we're finding what? R, and R is always positive. If we were finding an x or a y, we would consider plus or minus. So there's 13, and this is also 13 for what it's worth. Okay? Those are the two triangles. But yeah. No, there's no dumb questions. Oh, yeah, that one was dumb. No, the radius? Yeah, R is always positive. Okay. All right, so let's go ahead and list all 6 trig functions. We already were given one, but just to kind of stay habitual here, sine of theta, and I'm going to call theta to just regular theta. That's the one we want. So sine of theta, cosine of theta, tangent of theta. Those are the big 3. And then over here, the reciprocals, cosecant of theta, secant of theta, and cotangent of theta. Sine of theta. Okay, so it's y over r. Y over r. We're looking at this one now. Okay, so that's what? What's y over r? That's x over r. Negative 5 over 13, right? Y height. Right? Right? Y height, y. Okay. Oh, that's a bad. Yeah, there we go. Let me redraw that. There we go. Cosine, Daro. Negative 12 over 13. Good. Tangent is y over x. That's negative 5 over negative 12, which is 5/12. And that matches what we were given. So that's a good check. And now, if you know those are right, you can flip them, but let's go ahead and not do that. Cosecant is r over y, which is 13 over negative 5. So you can just call it negative 13/5. Secant is r over x. That's 13 over negative 12, which is negative 13/12. Again, you just pull the negative out front or put it in the top or bottom. It doesn't really matter. Cotangent is x over y, so that's negative 12 over negative 5, which is positive 12/5. And there you go. You have all 6 trig functions. So because it was a Pythagorean triple, we don't have any radicals there to contend with, right? They're just handsome, rational numbers. Good-looking group of numbers there. So you take a little while to celebrate, right? No one comes to the party, so you're done celebrating, you move on. Oh, that's sad. Yeah. Your free response, I'll walk you through there. I'll have you find the 6 trig ratios. Okay, now we need to find theta. So we just created 6 equations that we can solve for theta. As I mentioned, we probably want to stay away from the second column just because our calculator doesn't have those buttons, right? But we are free to choose any from this column. Now, which one of those 3 do we know for sure 100% is correct? Tangent. Now, because we're confident, pretty sure the others are correct also as well. But let's go ahead and use the tangent one. So here's all you have to do to show me which one you're using. If you take the inverse tangent of both sides, you're going to be left with theta equals inverse tangent of 5/12. That's all you have to show me. You don't have to show, bless you, inverse tangent of tangent. Just say theta equals that. Now I know which equation you're using. Okay. I'm about to hit the tangent button. What must I do first before I do anything, before I wreck myself? Check it. Yes. Go to your mode. People have been messing with these calculators since you last used them, maybe on purpose to mess with you, right? Make sure you're in degree mode because that's what it said. We're trying to find our angle in degrees. I am in degree mode. There we go. So now with second mode, quits, and we type in second tangent of 5 divided by 12. And remember, the calculator is going to give you an answer. It may not be the one we want. It gives us 22.619. I told tangent to give me an angle whose tangent ratio was positive 5/12. Guess which one it gave me? It gave me the other one in quadrant 1, right? So your calculator, more than likely, is going to give you an angle that you don't want. But remember what we said yesterday. And this is probably worth writing down. The all right. Probably worth writing down. Let's try it again. The calculator angles, reference angle, the angle that it gives you has a reference angle. And that reference angle is the same reference angle that you or we want, okay, for our angle. That's the one we want. So all you have to do then for your calculator's answer is figure out where does that calculator answer live, and how can I then find that reference angle from the calculator's answer. Once I have the calculator answer's reference angle, I've got my reference angle, and then we're going to do what we've been doing. We're using our picture. So in this case, if I can find the reference angle, I'm just going to add 180 to it. You see that? Because I need to get all the way over here to 180 plus the reference angle amount. 180 plus the reference angle amount. Yeah. Well, in this case, it's pretty darn easy because we already know that the other possibility for the tangent could have been in quadrant 1, and that's the one the calculator gave me. The calculator is always going to give you the first easier of the two angles, okay? So that is not only the first angle, that is the reference angle, right? So let's write that down. Theta ref is equal to 22.619 degrees. Okay, 22.619 degrees. So you always want to report it to 3 decimals. Now, all we have to do to find theta is add 180. So 180 plus theta ref. That's not a bad thing to show. That indicates your method. You tell me what you're doing. Now, I don't really have to store that value because it's right there on the previous line. So I just hit plus, and it recalls it, and then I put 180. Now, you're not always going to add 180 to a given angle to get the angle you want. It varies every single time. So there it is, 202.619. We always report 3 decimals. And we'll just report decimal degrees, not DMS here. Okay, and so you write it down, and there's the answer. There's the angle. We got the reference angle, which we found first this time, and then the angle we want, which we labeled theta. Let me just bring theta down again. Okay, so we can check now, right? Let's check. Go to the calculator. I'm going to store this one as alpha A. Store it as alpha A. If I take the tangent of that angle with all the decimals stored, even though the calculator, bless you, didn't give me that angle, it gave me 22, I can take the tangent of that angle that I found, and I should still be able to get 5/12. So there's a decimal. If you hit math, enter, you'll see it's 5/12. Sold. Grundy County Auction. Math, enter?
No, for the tangent thing, because before we did like the tangent with a little -1. So
Oh yeah, I'm just checking it by taking the tangent, right? Because that's what I wrote up here, right? I said tangent of the angle is 5/12. So I'm just plugging now in that I found it. I used the inverse tangent to find it, but now I'm checking. Now, you could check something else. Look, what should the cosine of that angle that we just found be? Negative 12/13. Let's try it. Cosine of that angle, which I stored as alpha A. Now we're just checking, right? You get that, which if you hit math, enter, enter, is negative 12/13. Go, gadget math. Hey, we might as well check the last one, right? So sine doesn't have his feelings hurt. Negative 5/13. All right. So sine of alpha A is this one. And then math, enter, enter, is negative 5/13. That means we found the right angle. Now let's do one other thing here. This is kind of crazy with the capital C. What if I wanted to verify the secant ratio? Ooh, how do I type in secant of my angle? Do I hit second cosine? Is that secant? No, that's not secant. That's the inverse cosine. We want the reciprocal of cosine. Don't do that. Okay, all you have to do is do 1 divided by cosine of alpha A. It's the reciprocal, right? If secant is the reciprocal of cosine, then it's 1 over cosine. You get that, and then you hit math, enter, enter. And you get negative 13/12. Reciprocals are 1 over, okay? 1 over. Cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent. Yeah. Okay, now, one last thing, because this is so much fun, I could tell. Y'all are having it. What if we didn't use tangent there? Remember yesterday when we used cosine, they gave us the answer we wanted? Remember that? And we're like, man, we should use cosine all the time. Well, that's fine. If you're certain that it's right, you could have chosen theta equals inverse cosine of negative 12/13. That's great. That's fine. Let's type that in. Okay, we're trying to find the angle now. So yep. Yes. Okay, so now because we're finding the angle, we'll take second cosine of the ratio, negative 12/13, and let's see if it does not give us our answer. Oh, it gives us 157. Is that our answer? No. Okay, so here's why. We told tangent or the calculator to give us an angle that had a negative cosine. Where is cosine negative? In which two quadrants? 3 and 4? 2 and 3. Cosine is x, right? So it's going to be here or it's going to be here. What did I tell you about those two triangles? They're going to be what? Congruent, okay? So if this is what you were typing in, you would have this as negative 12 and this is negative 12. You'd have this is 13 and this is 13. The only difference is they have different y values, right? This one was positive 5. This one is negative 5. But notice they are still congruent, which means they have the same reference angle. Yes. So how could I use my calculator's answer? Well, the calculator gave me this quadrant 2 answer. To find the reference angle, I'll do 180 minus that answer, right? So 180 minus that calculator's answer. And I did not type that in right. I'm an idiot. Today on a Friday, I gotta go through the Mondays. Okay. Tyler was never bored in this class. 180 minus second answer. Boom! There is our same reference angle. And now that we have the reference angle from our diagram, I did 180 minus this to get this. Now how do I get to my angle? I need to go all the way to 180 plus the reference angle. So now I can just add 180 back to that. And I end up with 202.619, which of course, our answer that we stored in A was 202.619. There you go. It doesn't matter if you use sine, cosine, or tangent. Those are the three easiest. The others, those are harder because you're going to have to flip the ratio first. So in essence, you're using sine, cosine, or tangent. Just figure out where the angle that the calculator gives you lands, in which quadrant. Find that reference angle, And once you have that reference angle, that is the same one that you want, and then use your picture to get where you need to, okay? That's a Two's Clues problem. It's lots of fun. Okay. How do y'all feel? Like you could do one on your own? No? Okay, good. Now I'll let you do it on your own. If cotangent of theta is -2, and I'll give you a hint since you're doing it on your own, that's -2 over 1. Because you're like, I don't even see a ratio. You could put it over 1. And cosine is positive. Determine the simplified exact value of their 5. Find the value of theta. Everything that we just did, okay? Everything that we just did. And while y'all are doing it quietly at your desk, I'm going to be doing it quietly at my desk. But I'm not going to show you my work. I'm going to freeze the screen. This is your free response question, essentially, next Wednesday. Better make sure we're in the white quadrant first. So here's what I got. Unfreeze. Okay. All right, so cotangent, -2/1. And, of course, that's the ratio x over y. So that means it's either -2 for x and +1 for y, or it could be +2 for x and -1 for y, right? If the ratio is negative, either the top or the bottom can be negative. So what quadrants does that put us in potentially? 2 and 4, right? So I labeled it -2, +1, or +2, -1. Now, from there, if you want to find the hypotenuse, it's fine. It's going to be the same for both of them. It's the Pythagorean theorem, square root of 5. But how do we figure out which one of those two that we want? Well, that's the second clue. The other clue was that cosine of the same angle was positive. Cosine is x over r. R is always positive. So if cosine is positive, it's because x is positive. And x is positive to the right of the y-axis. And so the only one of the two options that's to the right of the y-axis is the one I labeled theta 2. So our angle theta does terminate in quadrant 4. And that's the one that I highlighted there, okay? So if you hadn't done so yet, you would find the missing third side. It's not always going to be the hypotenuse, but it's always the Pythagorean theorem. We don't care about the negative one this time because it's still just square root of the radius, square root of 5. Okay, so there you go. So it ends up being +2, -1, and +5. So now that we have the right signs on the correct x's and y's, now it's just a matter of listing the ratios. So I did that right here real quickly. Pull them off the triangle. Sine is -1 over the square root of 5, but you got to rationalize. So when you multiply by square root of 5 over square root of 5, you get that. Square root of 5/5. Cosine, again, you rationalize. You get 2 square root of 5/5. Tangent ends up being -1/2. Then you flip them, or you pull them off the triangle. Cosecant is -square root of 5 over 1, so it's just -square root of 5. Secant is square root of 5 over 2. And cotangent is -2 over 1, which, of course, is -2, which is what we started with. Okay? So there's the trig ratios. If you have the wrong sign on your x and y, your sine and cosine, your secant and cosecant are all going to be the wrong sign. You're going to get 4 of the 6 wrong. Because if you have the wrong sign, it is wrong. All right, so I chose tangent. I chose tangent because it's the reciprocal of the given one, and it's also the most handsome. Now, when I take the inverse tangent of -1/2, I'm telling the calculator to give me an angle whose tangent is negative. That's going to be in quadrant 2 or 4. The calculator gives you -26. That's a quadrant 4 angle. It just gets there by going clockwise. So the positive version of that is the reference angle. So it's positive 26.565. Then to get to our answer, all we have to do is go all the way around, stopping that much short of 360. So to get our answer, it's just 360 minus the reference angle. Okay? And that ends up being positive 333.434. Okay? And that's the answer. And then you can check by taking the tangent of that. In fact, I have it sitting right here. If you just take the tangent of that answer, you should get -1/2, okay? And then you can check with the others as well. All right, so on Monday, we're not going to quiz. On Monday, we're going to finish this 2's clues problem, and I'm going to show you how to use the unit circle to get ready for Tuesday's quiz, okay? Yeah, and then test on Wednesday. So have a fantastic weekend. Don't not do math too hard. Make sure you get enough in there to have a good weekend.